Hey guys, in this video we will be going over the addition and subtraction of polynomials. So let's start with defining what a polynomial is. A polynomial in the variable x is a sum of terms of the form a times x to the n, where a is a real number and the exponent n is a whole number. So for example, x to the fifth plus 3x cubed minus 2x plus 4 is an example of a polynomial in x. And this is a polynomial since we can rewrite this as a sum of terms in the form ax to the n. Now remember, x to the 0 is the same thing as 1. So this is the same thing as 4 times 1, which is just 4. That's why we can rewrite it in this manner. Also notice that the polynomial is written in descending powers of x, since the powers of x decrease from left to right. Let's go over a few vocab words that we use to describe polynomials. Consider the following polynomial. The combination of numbers and variables separated by plus signs are called terms. We can always rewrite this expression as a sum in the following way. These are the terms of the polynomial. So we don't always have to rewrite it this way, but just remember to include the subtraction sign as the negative sign for the term. And the numerical factor for each term is called the coefficient. If no numerical factor appears in the term, like this term, then the coefficient is understood to be 1. And if the terms is only a number, like 5, this is called a constant. Now let's talk about the special names we give to certain polynomials. A polynomial with exactly one term is called a monomial. A polynomial with exactly 2 terms is called a binomial. And a polynomial with exactly 3 terms is called a trinomial. So let's create a table for organization. The following are examples of monomials, binomials, and trinomials. And each of these examples are also called polynomials. Now, each term of a polynomial also has a degree, and the degree of a term in one variable is just the exponent on the variable. So for example 1, let's identify the degree of each term of the following trinomial. The term 12x to the fourth has a degree of 4, since the degree is just the exponent on the variable. And the term negative 7x has a degree of 1, since x is also the same as x to the first power. And for the last term, since 3 is the same as 3 times x to the 0, this term will have a degree of 0. Each polynomial also has a degree. The degree of a polynomial is the greatest degree of any term in the polynomial. So for example 2, let's identify the degree of each term first, and then the degree of the polynomial. Again, the degree of each term is just the exponent on the variable. So negative 2x squared has a degree of 2, 3x has a degree of 1, and 6 has a degree of 0. So the degree of the entire polynomial will be the highest degree of the terms. Since 2 is the highest degree, the degree of the polynomial is 2. And for the other polynomial, 7x has a degree of 1, 3x cubed has a degree of 3, 2x has a degree of 1, and negative 1 has a degree of 0. And since 3 is the highest degree of the terms, the degree of the polynomial is 3. Now let's get into how to add and subtract polynomials. So to add polynomials, we just combine like terms. So for example 3, we want to add the two polynomials together. Normally, we would simplify what's inside the parentheses first, but since we can't combine anything inside those parentheses, we can just remove the parentheses. Now we want to combine the like terms. Negative 6x squared and 5x squared are like terms, since they have the same variable raised to the same power. And 2x and negative 2x are also like terms. So we have 4x cubed minus 1x squared after combining. And then the 2x and the negative 2x actually cancel out, plus 7, which can also be written as 4x cubed minus x squared plus 7. Another way this question could have been asked is in function notation. So for example 4, we have f of x equals 7x cubed minus 2x plus 7, and g of x is 6x squared plus 1. And we want to find f plus g of x. So another way to write this is f of x plus g of x, which just means we want to add the two functions together. So we take our two functions, f of x and g of x, and add them together. Again, we can just remove the parentheses and then combine like terms. This then simplifies to 7x cubed plus 4x squared plus 8. Now to subtract polynomials, we will need to change the signs of the terms of the polynomial being subtracted, and then combine like terms. So for example 5, let's subtract the following polynomials. Now normally we would just drop the parentheses when adding. So we can get rid of the parentheses for the first polynomial, but this time we have a minus sign in front of these parentheses. We will actually have to distribute this negative first in order to get rid of these parentheses. So distributing the negative, we get negative 2x squared plus 11. So notice how the signs for the second polynomial all changed after we distributed the negative. Now we can combine the like terms, and we get 3x squared plus 8. Again, we could have the question asked in function notation. So for example 6, if we have the two functions f of x and g of x, we want to find f minus g of x and f minus g of 2. This is also the same thing as f of x minus g of x, which means we want to subtract the two functions. Don't forget to include the parentheses initially. So for the second step, we drop the parentheses for the first polynomial, but for the second polynomial, since we have this minus sign in front of it, we have to distribute this in order to remove the parentheses. So we get plus x squared minus 2x plus 6, and now we can combine the like terms. This will then simplify to 10x squared minus 6x plus 8. So this is what f minus g of x is equal to. Now we want to find f minus g of 2. All we are doing is plugging in 2 for x into f minus g of x. So we have 10 times 2 squared minus 6 times 2 plus 8. This simplifies to 10 times 4 minus 12 plus 8, which is 40 minus 12 plus 8, and then we get 36. Therefore, f minus g of 2 is equal to 36. And the last thing to mention is that the domain of a polynomial in X will be the set of all real numbers, since we can plug in any X value in and always get a value for Y. So for the following polynomial, no matter what you plug in for these x variables, you will always get an answer for y. And again, this can also be written in function notation.